podcast. Here we're in the Solving Systems with Matrices, Activity 3.2. Matrices can be used to solve a system of equations. A system can be written as a matrix equation or equation with matrices. Consider a system of three linear equations and three variables written in standard form: ax plus by plus cz equals d. The system can be written as a matrix equation, ax equals b, by writing it as a product of a coefficient matrix and a variable matrix equal to a constant matrix. A coefficient matrix is a square matrix that consists of each coefficient of each equation of the system of equations ordered when they are written in standard form. A variable matrix is a matrix in one column that represents all the variables in the system of equations. A constant matrix is a matrix in one column that represents each of the constants in the system of equations. In a system with n equations, the coefficient matrix will be an n by n matrix. The variable matrix will be an n by 1 matrix, and the constant matrix will be an n by 1. So take a look at this worked example. We're going to use this on the next page. All right. Now, verify the matrix equation is equivalent representation of the system of equations. Use matrix multiplication to calculate ax equals b. Okay, so to do that, we're going to multiply. Now, when you multiply a by x, you multiply this by these. So that becomes 2x minus 1y minus 2z, and that's going to equal this value, so 3. Okay, so then we multiply this by this, so that becomes 3x plus 1y minus 2z equals 11. And again, this by this equals that. So negative 2x minus 1y plus 1z equals negative 8. Now, to write this as a system, this is 2x minus 1y minus 2z equals 3. This is 3x plus 1y minus 2z equals 11. And negative 2x minus 1y plus 1z equals negative 8. All right, go ahead and finish it up. Let's take a look at question number 2. Write each system equation as a matrix. So basically, you're going to write this in the form of ax equals b. So our A matrix is 1, 2, negative 1, 2, negative 1, 3, negative 2, 1, 2, times x, y, z equals negative 8, negative 1, 13. Okay. Now, this one's a little different in that we need all the variables on one side. So we need to take 5x equals negative 4y, and we need to add 4y to both sides. So now we have 5x plus 4y. Now we need a z, so we're going to actually include the plus 0z equals 0 because that's 0. Okay. So now we can include that here. So 5x plus 4y plus 0z equals 0. And the reason why we added the 0z is because we need a z in there. So now we have 3, 5, negative 1, 2, 4, 2, 2, 0z. And the reason why we added that, and we can add that because 0z equals nothing. So we've added nothing to the equation. We can do that, okay? But we did it as a placement holder, so we have a z there. and then that's negative 1 equals x, y, z equals 4, 0, 12. Oh, that X looks kind of funny. Let me try to fix that. All right, so go ahead and finish up number 2. We're going to ignore this problem, so let's move on to the next page. All right. Now, remember you can use technology and matrices as a tool when solving, okay? Now, we can actually solve this matrix, okay, with this concept. A, x equals B, okay? We can multiply A inverse by both sides. A inverse times A becomes 1. So to solve AX equals B, we just have to multiply A inverse times B. Okay, so let's go ahead and do that in Desmos. Okay, so I want to use matrix calculator. I'm going to put in the new matrix, and that's a 3 by 3. There we go, 3 by 3. Now let's put the numbers in. So 2, negative 1, negative 2, 3, 1, negative 2, negative 2, negative 1, 1. Press enter. And then we just need B. So B is a new matrix, which that's a 3 by 1. And then we're putting in 3, 11, negative 8. And then now we do A inverse times B. And there's your solution, 2, 3, negative 1. Which basically that's what I've done here. I've basically used Desmos to show this, but you can see our solution is 2, 3, negative 1. All right. Now, we're not going to worry about this question, so let's move on to the next page. All right. You're welcome to read this if you want. I'm going to go and jump to Desmos here, okay? Now, we're going to use Desmos to solve many solutions and no solutions. So I'm going to clear this out. So new matrix, 3 by 3. So I'm going to put in 1, 5, negative 2, and then 2, 10, negative 4, 1, 1, 3. Press enter. New matrix, 3 by 1, and that's 3, 6, negative 1. Now I do A inverse B. You get an error message. Okay, it's saying it's singular. That's a sign that it's either many solutions or no solution. When that happens, you have to do this without a calculator. Okay, so to do that, let's call this equation 1. Let's call this equation 2. And let's call this equation 3. Okay, now if I multiply equation 1 by negative 2 and combine it with 2, I should be able to eliminate variables. So let's do that, okay? So negative 2 times this is negative 2x minus 10y plus 4z equals negative 6. That's equation 1 multiplied by negative 2. Okay, now we're just going to take equation 2. All right, so this becomes 0, this becomes 0, this becomes 0. So 0 equals 0. So when you're left, when all the variables are eliminated of the true statement, we say that's many. And actually, let's use the correct term, infinite. We say that that's infinite solutions. Or I guess you could say, I don't have to, I guess, mark it out, but I'll put it in parentheses. I guess many is another way for infinite. So it's infinite solutions. Okay. All right. Let's take a look at no solution. Okay. So let's try with our matrix. So new matrix, 3 by 3. That's 1, 5, negative 2, 2, 10, negative 4, 1, 1, 3, and then new matrix, 3 by 1, 3, 7, negative 1, and then we're going to do A inverse B. Again, we get singular matrix, so that means it's either no solution or infinite solution. So now we have to work this out without technology. So let's call this equation 1. Let's call this equation 2. Let's call this equation 3. Now, I'm going to multiply equation 3 by negative 2 and combine it with 2. So let's see what happens. So equation 2 is 2x plus, and actually, wait. No, I'm sorry. Let's multiply equation 1 by negative 2. So negative 2 times x is negative 2x. Negative 2 times 5y is minus 10y plus 4z equals negative 6. And then we're going to combine it with equation 2. So that's 2x plus 10y minus 4z equals 7. So this was equation 1 multiplied by negative 2, and then this is equation 2. Well, this becomes 0, this becomes 0, this becomes 0, so you're left with 0 equals 1. Well, 0 will never equal 1. When all the variables go away and you're left with a false statement, we say that that's no solution. All right? So basically, we did number 5 right here. Okay? All right, let's take a look at the next page. All right. Write two of the equations in systems of 3 linear equations are given. Okay? Write a third equation that would produce a system with no solution. Explain the reason. Okay? So I went ahead and added the third equation, okay, for no solution. And I'll show you how that works out to be no solution. Okay? And actually, I'm going to have you work (6a) and 6b. So I've given you the third equation. Now I want you to show me, explain how that gets no solution, explain how this would be many solution. And really, again, we should say infinite many solutions, okay? All right, let's take a look at number 7. Okay, write each system of equations as a matrix equation, then calculate the solution to each system of linear equations by using technology. So first, we need to write this in the form of AX equals B. Okay, so this is 2. This is technically 0x plus, so 0, 1. Now we look at the y's. That's negative 3, 1, 2. And then the z's are negative 3, 1, 4 times x, y, z equals 7, negative 5, negative 17. Okay, so let's go ahead and use Desmos. So new matrix, 3 by 3. So that's 2, negative 3. Negative 3. Make sure you're careful on how you're typing. Negative 3. 0, 1, 1. 1, 2, 4, enter, and then new matrix 3 by 1 is 7, -5, -17. Press enter, and then all I have to do is A inverse B. So then X equals -4, Y equals -3.5, and Z equals -1.5. Okay, so X equals -4, Y equals -3.5, Z equals -0.5. All right, you work B, C, and D on your own. Let's take a look at the next page. All right, and then you work the talk to talk. Okay, so go ahead and read through that. You're going to do part A. Part B, you can ignore this, and then you're going to answer C. All right, go ahead and finish that up, and have a wonderful Wildcat day.